Hi, this is Victor and welcome back to my math tutoring channel. In this video, we have an infinite series and we have to show that it converges and we have to find its sum. The series is the sum of n equal to 1 to infinity of 1 divided by n times n plus 1. The technique that I will be use here is the partial fraction decomposition. So the partial fraction decomposition, it's not only for integral, you can use it in series too. So I can simplify this expression if I use the partial fraction decomposition. So 1 divided by n times n plus 1, I can write it because n is degree of 1 and this is to the power of 1, both of them. So it is a divided by n plus b divided by n plus 1. So now I have to find the common denominator on the right hand side of my equality. So 1 divided by n times n plus 1 is equal a times n plus 1 plus b times n, all that divided by n times n plus 1. Since I have the same denominator on the left hand side and the right hand side of my equality, I can take it out. I can simplify by it. So I would have 1 is equal, and here I will multiply a by n plus 1, which become an plus a plus bn. I realize I have two terms that has n as coefficient. So I would say 1 equal a plus b times n plus a. And if I look on the left hand side of my equality, I don't have anything with coefficient of n. That means my a plus b is equal to 0. And the one that does not have a coefficient of n on the right hand side is a, and on the left hand side is 1. So my a is equal to 1. From that I can deduct that a is equal minus b, and since a equal to 1, my b is equal to minus 1. So I will highlight those, I will use them. So now I can write the sum of n equal 1 to infinity of 1 divided by n plus 1 is equal the sum n equal 1 to infinity of a, which is 1 divided by n minus 1, because b is equal to minus 1, minus 1 divided by n plus 1. Because here I found a equal 1, b equal minus 1, so I can write 1 divided by n times n plus 1 is equal 1 divided by n minus 1 divided by n plus 1. Minus 1 divided n plus 1. And here I replaced 1 divided by n plus 1 by 1 divided by n minus 1 divided by n plus 1. So if I take the first term, when n is equal to 1, I would have the sum. I don't have to write it, the sum. If I take the first term, it becomes 1 divided by 1, because n is equal to 1 on the first term, minus 1 divided by 1 plus 1 is 2. Yeah? If I want to take the second term, where n is equal to 2, and I'm calculating the sum, so I would have to put plus 1 over 2 minus 1 over 2 plus 1 is 3. And the third term, plus 1 over 3 minus 1 over 4 plus 1 over 4 minus 1 over 5 plus etc. plus 1 over n minus 1 over n plus 1. So I realize minus 1 half plus 1 half minus 1 third plus 1 third minus 1 over 4 plus 1 over 4 and minus 1 over 5. And then here I would have minus 1 over n plus 1 over n. So my series, the sum of n equal to from 1 to infinity, I would have this term, which is 1, minus that term, 1 divided by n plus 1. So when n goes to infinity, 1 divided by n plus 1 is equal to 0, because 1 divided by infinity is 0. So my sum of n equal 1 to infinity of 1 divided by n plus 1 is equal to 1. So that means that series is convergent and the sum is equal to 1. If you like my video, please subscribe to my channel. That would encourage me to do more videos for you and it will help me tremendously. And if you push the like button, I would really appreciate it. Thank you for listening.